All right, practice quiz number 2 starts you off here with a polygon asking for the sum of the interior angles. Jace, how many sides are on this polygon? Okay, what do we call a 6-sided polygon? Do you remember? It is called a hexagon. Nice job. Yeah, this is called a hexagon. The important part is, as Jace said, that it has 6 sides. So remember, we have a formula, the interior angle of a polygon theorem, that says if you take the number of sides that a shape has and subtract 2 and times that by 180 degrees, you'll have the sum of the interior angles of any polygon. So Jace said this had 6 sides. Now we're subtracting by 2 because that's going to give you how many triangles it has. Remember what we originally did is we circled one of the vertices and then we connected all the non-adjacent vertices to that one. And that split the shape into triangles. This shape has 4 triangles. And each triangle has 180 degrees. So that's why we're going to do 4 times 180. Now, you don't have to split your shape into triangles if you can just remember to subtract 2. There's always going to be 2 less triangles than the number of sides. So Maddox, what is 4 times 180? Yep, every hexagon has 720 degrees. Now, even if you've memorized that hexagons have 720 degrees and pentagons have 540 degrees and quadrilateral, whatever, make sure you still show your work so I know that you're familiar with this n minus 2 times 180 formula, okay? Number 2. This one wants us to find the value of x. So it's going to require us to do an extra step. Find out the total number of degrees and then set up an equation. And yes, your quiz tomorrow is going to ask you to set up an equation. Is this polygon concave or convex? What do you think, Garrett? It's concave. It's actually on the top there, it goes back into itself, and that's going to make this concave. The nice thing about this formula is that it works regardless of whether you have concave or convex polygons. So how many sides are on this concave polygon? Deegan? What do you call a 5-sided shape, Deegan? It's a pentagon. Yep, so it's got 5 sides minus 2 makes that 3 triangles. And Garrett, what's 3 times 180? Oh, sorry. I forgot I just called on you. I was thinking Dawson, probably because his last name's Garrett. You said 540. Garrett's got his problems in for today. There's 540 degrees in this pentagon. Now that's part 1 because this is a 2-parter. Now we have to solve for x. So we have to add all these together. And you can save yourself a little bit of time. I'm not going to require you to start from scratch, but I do want you to write an equation. So my equation is going to be set equal to 540. Dawson, if we add 8x and x together, what's that give us? Okay, so combining our like terms. And then Dawson, 74 and 106. 270? 106 plus 74? What is it? 180, okay. You already subtracted it away, didn't you? Did you do 540 minus 180? That's pretty good. Oh, darn it. I knew that. I was having them slow it way down for us, okay? Now, obviously, the next thing you would do is add 90 degrees onto that. Let me catch up. All right, and you said that was what now? 270? That makes way more sense. I should pay attention to the problem. Okay, there's our equation. So if you want to start from there, that's perfectly fine. Jimmy, what's our next step in solving this equation? And what is 540 minus 270? That's 270. And our next step, Jimmy? Excellent. And what is that? So x is going to equal 30. It doesn't say find the measure of the missing angles. Otherwise, we would know that this angle up here is 30, and we'd have to times by 8 to see what that is. Now, this angle, that would actually be over 180 degrees. Because this exterior angle is obtuse, but this is way obtuse. And actually that's not called an obtuse angle. That is literally just the, I guess, I don't have a word for that. There's not a word that says they add up to 360. I was thinking complement, supplement, those wouldn't work. It really is just the opposite of that angle. So this is going to be closer to 360 than what it is anything else. Okay, so, but that's why it's concave. Those convex polygons that we're used to seeing don't have any angles like that. All right, number 3 is our next one. Number 3 says find the measure of each interior angle. This is a regular polygon. Who can tell me what it means to have a regular polygon, Brady? That's exactly right. In a regular polygon, all the angles are congruent to each other and all the side lengths are congruent to each other. So this is a regular what? Lizzie? Octagon. It's a regular octagon, has 8 sides. So using our formula, 8 minus 2 times 180, that's going to tell us how many degrees an octagon has. Lizzie, do you know how many degrees an octagon has? 1080. So 1080 degrees in this octagon. How do I find the measure of each of these angles? Xander?
Divide by 8.
Yeah, if it's, and you can only do this if it's regular. Because if it's not regular, they'd have to give you all the other one, like this one here. But if it's regular, they're all going to be equal. So you can split them 8 ways. And Xander, what's 1080 divided by 8? 135 what? Degrees. Yeah, sorry, I think I cut you off. 135 degrees. Yes. Reflex angle. Okay. I should add that to your vocab crossword puzzle this week.
Yeah. We just learned it. How are we going to learn about something? What is that? It's not that hard.
It's just one more word. All right. Now, what's the difference between this pentagon and the other pentagon we just did here, Lucy? Yes, nice job. These are exterior angles. And that makes a difference because the interior sum theorem and the exterior sum theorem are different. The interior angles are going to continue to grow with the more, like this octagon had 1080 degrees. The exterior angles, no matter what, for any sided polygon, are always going to add to the same thing. Lucy, do you remember what exterior angles will add to? No? Shane, you remember what they add to? It's always 360. Exactly. So all the exterior angles of a polygon are always going to add to 360. And again, that's because the more exterior angles it has, the smaller each of them are. And so it's even though you think it'd get really large, they actually all stay at 360. So I'm going to create an equation to find the value of x. And I know that my equation is going to be equal to 360. And it doesn't matter if this is a pentagon, hexagon, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, does not matter. 14gon, doesn't matter. They're always going to add up to 360. So let's start by combining our like terms. Emerson, what's x? X, 2x, and 2x. Okay. And then we have this extra 138 degrees. I'm not missing any right angles, am I? Dawson, no? Okay, good. Double check. All right, Martin, what's our next step? Excellent. What's 360 minus 138? Okay. You said 222? And our next step, Martin? Awesome. Divide by 6, and that's going to give us just 37. Yeah, and you could put degrees. I'm not going to count off if you put degrees. I will count off if it says find the measure of an angle and you don't. Okay, but yeah, 37 degrees or 30. So x is 37. If it said find the measures, you'd say 37 degrees, and then you'd say, let's see, 37 times 2, 74 degrees for the 2x angles down there. And if you do all that math and you add 37, 37, 74, 74, and 138, you should get 360 degrees. Number 5. All right, moving into section 3.4, where we talked about similar triangles. One of the newer things we learned from that section wasn't how to find the missing side of a similar triangle, because we've been working with proportions for a while. It was, if you can prove that 2 angles in a triangle match up, the third one has to. Because if you can have 2 of them, you know they have to add up to 180. So if you know 2 of them are the same in both sides of triangles, the third angles also have to be the same because they're going to add up to 180. So I can see here that there's a 48-degree angle, and that matches with another 48-degree angle. Now, at first glance, you know 23 is not 111, so those don't match up. So we're going to have to do a little bit of math to see if the 23 matches with this angle right here. So what's 180 minus 159? By the way, 159 is what 111 and 148 is. What is that, Christian? 21 degrees. All right, so close but no cigar. These are not going to be similar. And if you're wondering, on the test tomorrow, how would I show my work for that? You'd show me that you found what the other angle was, and I know that it doesn't match. So again, if you're curious, we did 180 minus 111 minus 48, which is the same as subtracting away. What I say that was 159. And that's going to give us 21 degrees. So I don't even have to find X. If I know that Y is not 23 degrees, then X isn't going to be 111 degrees. All right, number 6. Same thing here. Of course, these right angles are going to match up. Now, it looks like they wouldn't be similar, but they could have rotated this. So your choice, find A or B, but we need to figure out if A is 51 degrees or if B is 39 degrees. Somehow we have to figure this out. So Sky, do you want to find A or B? Okay, so take 180 and I want you to subtract away the 90 and 39, which makes 129, and see what we got left. Ah, it's 51 degrees. So if we can prove that 2 angles match up, the third pair automatically will match up. And in triangles, that's all you need. They're similar. If the 3 angles of a triangle are similar, that triangle is guaranteed to be similar because, sorry, if the 3 angles are not similar, that's not what I meant to say. If the 3 angles, corresponding angles, are congruent, the triangle is guaranteed to be similar. That is not true in rectangles. We know that, right?
Yes.
Because all the corresponding angles are going to match up in a rectangle, but a 3x5 rectangle isn't the same as a 1x2 rectangle. They're not similar. They have to be proportional. Sides have to be proportional. Here, the sides are guaranteed to be proportional because it's a triangle. Triangles are just like that. Okay. All right, number 7. Find the value of X. Well, this is only going to work. This is only going to work if I can prove the 2 triangles are similar. So we did one like this on Friday. How can we prove these 2 triangles are similar? Go ahead, Deegan. Aha, yes. So we know that these angles are going to be the same. So they match because they're vertical and congruent. What's the other set of matching angles? Oh, interesting. So these 2 90-degree angles are going to be the same. And if we can prove there's 2 pairs of congruent angles, the third pair will also be congruent. By the way, there's another way you could prove it too. Not that Deegan's wrong. I would have done exactly what he did. But if I extend these lines, what do I call this purple line? What do I call that purple line? Oh, sorry, I didn't see your hand. Yes. A transversal. Yeah, that purple line's a transversal. And we have this theorem called alternate interior angles are congruent. And so you can actually prove, when we get rid of the lines now, that those 2 angles are the same by thinking of them as extended lines. So they are similar triangles. We can agree with that. So since they're similar triangles and we're wanting to find side lengths, we should set up proportions. So X corresponds to the 12-foot or 7-foot side? Jimmy? The 7-foot side. So X over 7 go back to the small triangle is the same as 3 over 12. Use cross products. 12x equals 21. Carter, how do I solve that equation?
You do 21 divide by 12.
And I'm going to have you do that for me.
1 3/4 or 1.75.
1.75. So we'll say 1.75 feet. By the way, how many inches are in a foot?
That would be.
This is for anybody. Shout it out. 12. Okay, we all know that. Good. 12. If I said 0.75 or 3/4 of a foot, what's 3/4 of 12?
8.
That's 2/3 of 12. 9. So if I was asking for inches, which I am not, you'd have 12 because 1, and then you'd have 9 more for the 3/4, and you would say 12 and 9 is 21 inches. Which is just a coincidence here that we actually get 21 when we multiply 3 and 7. That's just a coincidence. I was going to say, wow, that was weird, but just a coincidence. Number 8, the value in degrees of each of the interior angles of a regular n-gon is represented by x. So each of the angles inside this n-gon are x degrees. Now, when it says n-gon, that means it could be whatever size you want it to be, except it can't be one-sided or two-sided. The smallest polygon we'll have is a 3-sided polygon. Write an inequality that describes the minimum value of x. Lizzie, you think you got it? That is absolutely correct. Now, how did you get 60 from all that? Technically, it does. It absolutely counts. So the smallest sided polygon you can have, of course, I say small sided because I can make it as big as I want to. Smallest sided polygon you can have is 3 sides. Last week, we said that there is a regular triangle. It exists. It's called, and Owen's not here today to repeat it, equiangular and equilateral. Well, if it's equilateral and all 3 sides are the same, all 3 angles are going to be the same, and all 3 angles, if you take 180 divided by 3, are 60. So since x is the measure of each of these, 60 degrees is as small as you can get, because if you make it a regular quadrilateral, what shape are we going to be talking about? A regular triangle is equilateral triangle. What's a regular quadrilateral? A square. And that's going to have 90 degrees. A regular pentagon is going to have 540 divided by 5 degrees. A regular hexagon is going to have 720 divided by 6 degrees, and so on and so forth. So 60 is as small as those interior angles can get on a regular shape, regular polygon, because you can't have a 2-sided polygon. All right, number 9. A swimming pool is in the shape of a regular decagon. How many sides on a decagon? Garrett? 10, just like there's 10 years in a decade, right? So decagon has 10 sides. One edge of the pool is directly against the outside wall of the house. Find the measure x of the angle between the house and the pool. So it's wanting us to find one of the exterior angles on this decagon. I've already heard from you. I haven't heard from Connor yet, though. Connor, it's got 10 sides. What do all the exterior angles add up to? Doesn't matter how many sides it has. They're all going to add up to 360. They could have said this was a regular square pool. Still adds up to 360 when I'm talking about the exterior angles. So if all the exterior angles are going to add up to 360, regardless of whether it's a decagon or whatever, then Connor, what's 360 divided? By the way, how many sides? 10. Okay, so 10 sides means it's going to have 10 angles. Each exterior angle is going to be how big, Connor? 36 degrees. Yep, when it says find the measure, we want to put that degree symbol, 36 degrees. The only thing that the decagon part actually plays in this is what are we going to divide it by? Because if there's 10 interior angles, there's also 10 exterior angles. But the 360s, that's just known. We know that if we're talking about the outside of the shape, they're all going to add up to 360 degrees. Number 10, You want to know the total width of a 4-lane highway. So you take measurements on your side of the highway so you don't die. You make this drawing. And so X is the length of this entire side AB here, which I've coded and colored in purple there. We again can prove that they are the same according to Deegan. That's because they have two right angles. There's one set of matching angles. And because these are vertical angles, there's another set. And so therefore the acute angles on the opposite ends, B and D, have to be congruent as well. So they're similar. What proportion can we set up to solve for X in this? Chloe, I haven't heard from you yet. What's the proportion that we could set up that involves X in it? She doesn't like to be put on the spot. I'll start you off, Chloe. It's going to have an X on the top. Not that it needs to be there, but I feel like that's a good spot for it. Chloe, which of those sides of the triangles corresponds with side AB, which is the X side? The what? The DE, yeah, the 90 feet. Nice job. Okay. So if side X corresponds with the 90 side, DE, then go back to the triangle on the right side. Chloe, what's the other side we have on the triangle on the top right? AC, good. That's 30 feet. And that's going to correspond to the CE side, which is how many feet? 25. Okay, thank you for helping us build that proportion. Julia, 25x equals what? Okay, and go ahead and divide that by 25. 108, and that's going to be measured in feet. So let's see how they want us to answer this. It says, which statement is true? Okay, so I got to make sure I've got the right similarity statement. Similarity statements work just like congruent statements. You got to match the corresponding angles up, and the corresponding sides will automatically match themselves up. So it says triangle ABC. By the way, let me go ahead and put these little marks here so we know which of the angles correspond. So there's, you got the right angle, you got the 1-tick angle, and you got the 2-tick angle here. So ABC goes from the right angle to the 2-tick to the 1-tick. CDE does not start at the right angle, so that's not it. So you can't say that's your similarity statement. Now ABC, you could say, let's see, E to C to E, where's my point? There we go. E to C to D. No, E to D to C. Yes. I keep looking at the one below it. And that's not going to work either, because ABC goes goes to the right angle to the 2-tick to the 1-tick. But EDC goes from the right angle. Oh, no, that's what we wanted, to the 2-tick, right? Yeah, I kept thinking it was going to go up to C. I keep looking at the one down here. Yeah, that one's right then. There we go. That one's right, because that one's it's gonna match up those corresponding angles. And then we have found it was 108 feet. That should be it. So, assuming that you're done with it, go ahead and pass your papers to the front, making sure your name is on it. Submit first. Make sure you have 100% on it. If you miss something, it's not my fault, it's yours. I can unsubmit it for you. You don't hit it. Yeah, just put 108. Good question. Shane, just type in 108. Shane was asking how we type in feet after our answer. Just put it on your paper and type in 108.